Hello, today in class we're talking about the limit of multi-vari functions. Since I've already taught myself this kind of stuff in China, I want to share some tips for solving such questions. And I have to apologize for my poor spoken English and my terrible handwriting since I'm using a mouse, but I hope you find this video helpful. So normally we let x and y to become a linear function, which means, okay, I'm approaching from any directions because I can have different k, which is our slope. Okay, you use m in America, but we use k in China. But anyway, so for the first, let's talk about the first question, and you will understand what I'm talking about the concept. So because x and y they're both approaching to 0, so we can let y equals to kx or mx, and we don't need b here because we don't need the y-intercept is 0 when x goes to 0. So we just do substitution. We let y equals kx back into the function we have, and I'm not gonna write down the limit notation anymore again and again because I don't want to waste time on that. So anyway, so it will be x times kx, because y is kx, divided by x squared plus kx squared, and it equals to, you can factor x squared, and that would be k divided by 1 plus k squared. So we got this, which means the limits from different direction has different limits, which means the limit does not exist because they have to give the same value. So when you do the substitution, if you find a limit that is not depends on k, not depends on the slope, that means the slope. That means the limit exists. But in this case, it does not exist. So let's talk about the second question. And the second question is a little tricky because we have sine of xy divided by x. It's not this kind of functions anymore. But we can still use the like linear. I call this like normal method. So let's let y equals to kx plus b. So in this case, the b is 2 because the y-intercepts are 2. So y equals to kx plus 2. And we do the substitution, we would have sine of kx plus 2. So x times kx plus 2, in parentheses, divided by x. So it's the same thing if you have divided by k times kx plus 2 times kx plus 2. Okay, why I got this? Because x approaching to 0, which means the whole thing approaching to 0, and the whole thing approaching to 0. And since it's homogeneous, because it's x times kx, which is x squared, and this is x times kx, which is x squared, which means they are approaching to 0 at the same speed. So that, and we have a very important limit, which is sine of ax divided by x when x approaching to 0, that gives you a. So in this case, this approaching to 0, this approaching to 0, so the how do you say that word? The coefficient is 1 here. So the whole thing gives a limit of 1. And we have x approaching to 0, so this part is 0, and we plus 2. So this whole part is 2. So we have equals to 1 times 2, it gives 2. Okay, and we have another way to do this question, which is a little simpler. Let's do it, but it's basically the same concept. So let's say sine, let me erase this part. Okay, so let's do, because we notice that sine of x times y is in the sine function. So what about we just let the denominator becomes x and y, because we know x approaching to 0, and the whole thing would give it a 0. So x times y will give 0. So if we let the denominator same thing as the stuff in the parentheses, we'll give it a 1 here. So it's the same thing, that times y, because we want to cancel the y. So it's the same function now, and that gives you a 1 times y, which is our 2, that gives it 2. So they are the same method, but I just write them in different way, and this is like a little neater and simpler or less complex. Okay, let's talk about the last one. We talked about this in class by using the Squeeze Theorem because we have x squared divided by x squared plus y squared, which is smaller than 1, right? And greater than 0, greater or equal to 0, and of course. So if we times 3y, that give you a 3y, because we don't know like y is negative or positive, so we need to take the absolute value. So because y approaches to 0, but so it doesn't matter if we take the absolute because it's approaching to 0 anyway. So we can also use the normal method we just like we talked about a lot in this video, which is we let y equals to kx. We don't need the intercept here because they're both approaching to 0. So we have the limit of, okay, I'm not gonna write the limit anymore. I've said that. So it will be 3x squared times kx divided by x squared plus kx squared. So we can factor a squared out, so we can cancel the x squared. So it's the same thing as 3kx divided by 1 plus k squared. Fair enough? So we have x approaching to 0, so the whole thing give you a 0 because the numerator will give you a 0. Or you can do another way is like this is x cubed, this is x squared, so this has like stronger, this is stronger, so it's approaching to 0 because it's basically x to the cube divided by x squared. And when x approaches 0, the whole thing approaching to 0, which means the limit is 0. And okay, well done for these 3 questions. And so let me finally give you the non-zero approaching method. So for example, we want to deal with the limit with x, y approach to x and y approaching to 2 and 4. So how do we do these questions? And we want to get y equals to kx plus b, right? Because that means it's from all different directions. But we cannot just say, okay, y equals 2x or y equals to x plus 4, or whatever, because we would have different intercept. Let me give you an example. If the point is 2, 4, which is right here, we can have a line here, we have a line here, we have a line here. Each slope will give you a different intercept. So we would have y equals kx plus b, and we just plug the point in, so it's 4 equals to 2 times k, which is our k, plus b. So we will have b equals to 4 minus 2k. Okay, now we have our new formula, which is y equals to kx plus 4 minus 2k. And now then you can do the substitution for y equals to kx plus 4 minus 2k as your y, and then plug it back into the original function to find the limit. And it's a little more complex, but we can still handle this. And thank you for watching.